Hello, friends. Today we shall take up a few numericals on reverse current braking. You remember last class we discussed about the methods of braking, reverse current braking, what is it, how it is done, and a bit of analysis also we did. Based on that, today we will take up one or two numericals. Look at this. Statement of this problem goes like this. A three-phase 440 volts 50 hertz 10 poles star connected induction motor has the following parameters: R1 0.15, R2 0.45, X1 0.6, X2 1.8 ohms, SF 0.05. The ratio of effective stator to rotor turns is 1 by root 3. The motor is to be braked at rated speed and an external resistance of 1.75 ohms referred to stator has been inserted into rotor circuit. Determine the initial braking torque if the method of braking employed is reverse current braking RCB. Okay, the statement of the problem goes like that. Now please take a pen and paper, try to figure out how you can proceed with the solution. Just sketch the approach. Not necessary to get the exact values, just the approach is enough. I will give a pause there. This is pause for you to try. Please don't fast forward. Use this time, it's very important. Go through the statement of the problem again. Try to understand what is given and what is asked and how you can proceed. Okay, this is a problem on plugging or reverse current braking. Okay, go ahead, try yourself. Good. Some of you have started trying. Please don't fast forward. In the 3 minutes I will give. Use the time, this pause. Good. 2 minutes more. Start writing, start scribbling. Let it go wrong, doesn't matter. Good. Continue. It's very important to try on your own. Reading the problem straight, it doesn't give you much of insight. Your understanding will not be clear. Good. Okay. Now Let us solve, look at the solution and then try to compare what you thought with the solution that is given here. So the problem is on reverse current braking. Is it okay? The problem is on reverse current braking. Reverse current braking is accomplished by interchanging the supply terminals that we know. The specification of the induction motor is given. It is star connected. P is equal to 10. Line voltage is 440. So obviously phase voltage will be 440 by root 3. And the parameters of the induction motor R1, R2, X1, X2 are given. Note, here it is not mentioned refer to stator. Obviously these two are the absolute values, not the referred values. SF is the full load slip. It is 0.05%. The ratio of effective stator to rotor turns is 1 by root 3. This is the ratio of the turns. And the braking is done at rated speed. That means when the braking is done, then the slip will be 0.05. And an external resistance of 1.75 ohms. Now this is mentioned. It is referred to stator. I can use it straight away. 1.75 ohms is inserted into rotor circuit when the braking is done. We have to determine the initial braking torque if the method employed is reverse current braking. First, we will have the equivalent circuit corresponding to motoring. That will make the things very clear. So equivalent circuit, when it is acting like a motor, there will be R1, it's approximate, there will be X1, there will be R2 dash, there will be X2 dash, and there will be phase voltage because this is per phase equivalent circuit. V phase is 440 by root 3, 254.3. R1 is given, X1 is given already, whereas R2, X2 are given. We will have to find out R2 dash and X2 dash. R2 dash is equal to R2 into that ratio, turns ratio square, and X2 dash equal to X2 into turns ratio square, and that will give us R2 dash as 0.15, X2 dash as 0.6. So with this, the equivalent circuit will be R1 X1, R2 dash we have got as 0.15 divided by the slip, X2 dash we have got it as 0.6. This is the equivalent circuit. And the synchronous speed is Ns 120F by P 600 rpm because P is given as 10 and F is given as 50 Hertz. So with that, the synchronous speed in radians per second will be 2 pi Ns divided by 60. We will get 62.8 radians per second. And it is mentioned in the problem that the full load slip is 0.05. That means this SF is 0.05 when the motor is operating at full load. This is the motoring mode. Very clear, na? Now we will proceed. When the braking happens, what type of braking? Braking is RCB. The supply voltage is 254.3 and the additional resistance 1.75 is added. Additional resistance 1.75 is added and it is already referred to the stator. I need not do the referring there. And now when it is this type of braking, the value of slip will change. It will not be forward slip, it will be negative slip. Here we have forward slip, whereas here it is negative slip. So what is negative slip? Sn Sn for the reverse phase sequence is 2 minus S for forward, and forward when the braking started, when the full load slip was 0.05, so it will be 2 minus 0.05, 1.95. And the additional resistance, this is RD dash divided by Sn. This is RD dash divided by Sn. RD dash is already given 1.75. Therefore, we can find what is asked in the problem, braking torque. What is the expression for the braking torque? Braking torque equal to 3 divided by omega ms IR dash square R2 plus RD dash divided by Sn. R2 dash plus RD dash divided by Sn. That is the equation. In this, IR dash we can find separately. IR dash is VPH divided by the whole impedance, and the impedance of the circuit, there is resistance, there is reactance, R square plus X square. R1, the rotor side, R2 dash plus RD dash divided by Sn, and then X1 plus X2 dash. Okay, so that is the IR dash. Now I have substituted for that. V phase is 254.3, R1, R2 dash, RD dash we have substituted. Sn is 1.95, and then X1, X2 dash 0.6 and 0.6, and this IR dash square, na? So VPH square, this root will vanish. That's why IR dash square will be this into 3 by omega ms. Omega ms we know already how much is the value, and this is R2 dash plus RD dash divided by Sn. This, with this we will get the braking torque as 1109 Newton meters. 1109 Newton meters. Very simple problem, no? Actually understanding took more time there. Understanding the problem. The solution per se is not very lengthy. Here the key is this, the clarity of the basics. Then suddenly we can link to the type of braking and then go ahead with the equations ready and then get the value. Is it okay? So here you will have the numericals of this type. We will take one more problem. So another problem, take this problem. Okay, a 50 kilowatt 400 volts 4 pole 3 phase 50 hertz induction motor has a full load slip of 4%. If the ratio of standstill reactance to resistance per phase of rotor is equal to 5, calculate the torque developed at the start of reverse current braking at rated speed. Neglect stator impedance and magnetizing current. Please go ahead as you did earlier. Try on your own. I will give a pause for you to try. Interesting problem it is. Very interesting. A few minutes you take. Try to solve it yourself. At least the outline you try to sketch. For that, how the solution will look like. Good. Don't fast forward. Don't skip. Please try to use this pause. Try to use this pause. It will be a good learning experience for you. 3 minutes I will give. Sorry. Go ahead. Some of you are trying. That's good. Problem is not lengthy. It's a very short problem, but teaches you. You will have to understand the statement properly. Good. Go ahead. Another 1 minute. Just sketch out rough. rough sketch. That's enough. Good. Hmm? Half minute more. Go ahead. Good. Okay. So now look at this problem. It is a problem on braking, reverse current braking. That is the very first thing that we should be clear. It is on braking. It is reverse current braking of three-phase induction motor. The very first thing. And this three-phase induction motor is with the ratings 50 kilowatts, 400 volts, 50 kilowatts. When it is told about a motor, what does it represent? Output power. 400 volts line voltage. 4 pole P number of poles. It has a full load slip of 4%, 0.04. If the ratio of standstill reactance to resistance per phase of rotary is 5, calculate the torque developed at the start of reverse current braking at rated speed. Neglect stator impedance and magnetizing current. Problem is made very simple. We will have to neglect the stator impedance, that means R1 X1 as well as Xm. It is only the rotor parameters which are there. If I take the rotor parameters as X2 reactance and R2 resistance, the referred values will be X2 dash, R2 dash. And what is told here is standstill reactance to resistance ratio is 5. There is the key. That is the key. The ratio this to this standstill. Standstill means S equal to 1. So X2 by R2, X2 dash by R2 dash is equal to 5. Done. Once that is done, then the other things you can easily do yourself. You will have to find the torque developed at the start of reverse current braking. At the start of reverse current braking, and when the braking starts, when the slip is 4%. So the braking you require Sn. Sn is 2 minus Sf. Sf is this. X2 dash by R2 dash we know. Go ahead, write the equations. Maybe you will have to solve two equations together to get the solution. Will you try? Please try yourself. I will give this as homework for you. Please take this as homework and try to do it. I have given ample clues for you to try. Okay? The first thing is draw the equivalent circuit. Very important. Draw the equivalent circuit. So I will give this as homework. You will have to try yourself. So we will take one more problem on this reverse current braking. It is thus. The problem is this. A 400 volts, 3 phase, 50 hertz, 4 pole case induction motor has the following equivalent circuit parameters: R1 0.1, X1 0.4 ohms, R2 dash 0.1 ohm, X2 dash 0.4 ohm. The motor was operating on full load at S equal to 0.05 when the two stator terminals are suddenly interchanged. Calculate the primary current and braking torque immediately after interchanging action. Immediately after interchanging action. Please go ahead. Go ahead. Interesting problem. Go ahead. Try yourself. I will give a pause, few minutes for you to try. Please try. Try on your own. Interesting problem. Read the problem yourself loudly. Understand the statement. Try to figure out how you can proceed. How you can proceed. A rough sketch. Read the problem properly, that's very important. Don't forward, no fast forward, don't skip. Please use the pause. Take a pen and paper, try, read the problem, scribble a solution yourself. Let it go wrong, doesn't matter, let it go wrong. 2 minutes more, another 2 minutes. Good. One more minute. Please try sketch out the solution approach yourself. Good. Another half minute. Some of you are trying, others please don't skip the pause, use the time. Good. So now see this problem. What is the statement? It is a 3-phase induction motor and the ratings are 400 volts. It is the line voltage. 4 pole P is equal to 4, F is equal to 50 Hertz. The equivalent circuit parameters are R1, X1 are given. R2 dash, X2 dash are given. That means the referred values are given. To that extent, the problem is simple for us. And the motor was operating on full load of 0.05. That means 5%. It was operating as a motor machine. Now, at that instant, the two stator terminals are suddenly interchanged. Look at this. When that is done, calculate how much current the motor will draw, primary current, and how much is the braking torque immediately after interchanging action. So, here, did you understand? Instead of telling it is reverse current braking, the statement is made like this. The terminals are suddenly interchanged. When the terminals are suddenly interchanged, the phase sequence will reverse and it is actually reverse current braking, plugging. So what is actually asked is the moment the plugging is done, at that instant how much is the current and how much is the braking torque. Very simple, na? Only this part. If this part is understood, it is plugging, and the other things you will go ahead yourself. There will not be much of problem. Okay, please try that yourself. First draw the equivalent circuit and then go ahead. We have already got the equations for the current and then for the torque. Please use and then go ahead. Take it as a homework. So today I will make this session little short because I have given 2 numericals as homeworks for you. Please try to solve those yourself. It is a must. I repeat, solving those numericals is a must. Please do longhand calculations. Take a paper and then calculator, sit comfortably and then try to solve yourself independently. Okay. With that, we will stop. Next class, we will continue our discussion. Bye. Take care.